set 81, and we are studying some ugliness. So, we are going to divide complex numbers like so. Remember, student hours after school today if you need additional help. Also, I would say on the test, if you don't know how to do everything on the last test, this one is just going to be harder. So take that time to seek. Don't be like, oh, I don't like my grade, and then crumple it up and throw it away. Like, take the time to seek out answers on those ones that you don't know. Otherwise, you're going to get those wrong and more on this one. Okay, like option there. Okay. How do I simplify this? I think we've already done this, right? Multiply by.
Oh, so
yeah.
B squared plus B squared.
Oh yeah. 4 plus 2i.
Yeah, you multiply by the conjugate. So you switch the symbol. So if it's a minus on the bottom, you change it to a plus. What is this for minus of? The difference of squares formula, right? A minus B times A plus B. I see your hand. I'll get to it eventually. So then we have 4 plus 2i. What do we do from here? Working vertically, because we want this to look sharp. I've noticed that a lot of you get sloppy on your exams and just stop writing the denominator and ignore it and forget about it. And then at the very end, you write something random. Each time, this should be equal to your next statement, which should be equal to the next statement. So don't just leave parts off because it suits you or it saves room. Okay? 2 times 4 is? 2 times 2 is?
4.
3 times 4 is? 3 times 2 is? -6. That's right. Because we have I times I, which is? I squared, which is -1. Okay? I did a little logical jump there. Okay? We're nearing the end of Algebra 2. We get to the point where we can do that. I'm still showing plenty of work, but sometimes you'll do some logical jumps. If you don't like that logical jump, this is 3 times 2i squared, which is -6. Okay? So, just for completeness. On the bottom, 4 times 4 is 16. We don't care about the middle terms because they'll cancel, right? That will cancel with that. So then we're left with plus 4. Why is it plus 4? This times this is -4i squared. I squared is -1, so that becomes plus. Okay? So what does this equal? Well, I combine or I collect terms. 8 minus 6 is
2.
2 plus 16i over 20. Now, it appears as if this can cancel. Something important that I want to share with you, and I will begin taking points off for, is that every complex number has a real part and an imaginary part. What's the imaginary part? It's the part with I in it. And so, as you write your answers, these are all equal signs, you have to split the real and imaginary parts. So this would be 2 over 20, which is 1/10, plus 16 over 20, which is 4/5. I. The imaginary part always goes second. The real part always goes first. If you have more than one real term that you can't add together, put them in parentheses. So you have your real parts collected and then your imaginary parts collected. Yeah?
Do we do that because of the difference of squares?
Nope, we do that because that is how you write a complex number. You always have the real part and then the imaginary part. They must be separate. In pre-calculus, we'll get into how we can actually graph those, how we can take cubed roots of numbers that you think you know the cubed root of that you really don't. Like, what's the cubed root of 8? 2? Sometimes. In fact, that's only 1/3 of the correct answer. And the 4th root of 16 is 2, but there's actually 4 answers. So, we'll get there. There's reasoning for this. I'm telling you now, you must write them that way. Okay? We'll get there. I'm sure Corbin will have it figured out in a couple of days, and that's fine too. Okay? Questions on this problem before I make it harder? All right, let's do another one. Now we have 4 minus 2i over 2i minus 3. Are we bothered that the I isn't second?
Yes.
No, I don't care. What's the process? Change the sign and multiply on the top and bottom.
But you have to do
that is.
Nope. Change the sign, multiply on the top and bottom. Why? Because it's our difference of squares. A minus B times A plus B.
What if we flip it? Then do we change?
Then you're still going to have to do difference of squares.
Yeah.
So go ahead and flip it and do it yourself and see if you get to the same answer. You just made more work for yourself. Sorry. Okay, 4 times 2 is? Everybody, come on. 4 times 2.
8.
8i. 4 times 3 is?
12.
Negative 2 times 2 is?
Negative 4.
Okay, so this is going to become plus 4. Negative 2 times 3 is? Minus 6. Okay, how did this get to be plus 4? 2i times 2i is what, Taylor?
4.
4 what?
Well, negative 4. 4 is negative.
And then the i's are?
I squared.
I squared. When we square I, it becomes negative 1. So that becomes positive 4. Okay, on the bottom, we don't care about the middle terms. 2i times 2i is?
Negative 4.
Negative 4. And negative 3 times 3 is? Negative 9. Did it work out your way? I'm not letting you off the hook.
No, it didn't.
Switch something.
It didn't work.
You gotta show your denominator.
Well, no, I don't get the denominator.
Yeah, but you have I squared. You get the same number.
No, because
I squared. So that becomes 13. And we have 13. All right. All right. So,
I have positive 13.
you do have positive 13. So what Jose is asking is, can we do negative 3 plus 2i times,
Negative 3 minus 2.
and he's going to get positive 13 on the bottom. Is the bottom the only thing that changes?
No.
No, that's why we have to show all of our work, because you're also changing the top. So you'll get an extra minus sign on the top. So you must do the whole problem and not just a small piece. Continue. I'm going to check at the end of this lesson. The suffering is real. Okay, so we have 12 plus 4 is 16. 8 minus 6 is over negative 13. Is this the correct answer?
No.
Wrong. This will lose points. Why, Anna? You have to split the real and imaginary parts. So this would be negative 16 thirteenths minus 2 thirteenths I. Rose? Yeah. That's fine. That's your whole lesson. So, you may begin on your homework.